In this video, I'm going to solve a couple more examples, exponential equations, starting with number 2 on page number 3. This is for Math 161 Pre-Calculus 1, and we're looking at section 3.5, solving exponential and logarithmic equations. We did go over log equations during class. We used all these properties, but we have a couple more exponential equations that we need to finish solving. So starting with number 2, I'm going to go ahead and, because the exponential expression is isolated on the left side of the equal sign, we're ready to just take natural log of both sides. So I'll say natural log of 3 to the 3x minus 1 is equal to natural log of 6. The reason I take natural log of both sides is because now I get to use the power property, where this 3x minus 1 will come down from the exponent. So I'll have 3x minus 1 came down in front of natural log of 3, and that's equal to natural log of 6. All right, I guess we can distribute natural log of 3, but I'm just going to do it this way, okay, if this is okay. I will divide both sides by natural log of 3 now. I am trying to solve for x. So I saw that the green parenthesis was getting multiplied by natural log of 3. So I decided to divide both sides by it. So that way this is canceled out. Okay, so the left side of the equal sign, I have 3x minus 1. And the other side of the equal sign, I'm just going to have to write this as a ln 6 over ln 3. Natural log of 6 divided by natural log of 3. All right, let's keep on going. What will you do to both sides? I will add 1 to both sides. So plus 1, plus 1. If we do that, we get 3x equals natural log of 6 over natural log of 3 plus 1, right? The next thing is to divide both sides by 3. So I will divide everything by 3. Divide this by 3, divide this by 3, and divide this by 3. So I am done. So the answer is x equals natural log of 6 divided by 3 natural log of 3 plus 1/3. And that is the exact form. I'm going to go in and now type this into a calculator so that we can get a decimal approximation. Okay, do have one right here. So I'm going to type in, let me get rid of some of these. I'll type in natural log of 6 divided by 3 natural log of 3, and then plus 1/3. And that comes out to be a decimal 0.87. I'll go ahead and round it up to 70, or maybe 3 decimal places instead of that awkward 0 at the end. So we solved one where we just take natural log of both sides and then go with the power property. And this is really how I solve almost any exponential equations. So maybe I'll do one more on this page, which is number 4. Okay, all right, let's start this problem. Before I take natural log, I'm going to have to first subtract 820 from both sides so that my exponential term is isolated. If I do that, I'll get 10 raised to the 8 plus 2x equals, all right, I'm subtracting on my calculator here, 49,600 minus 820. That comes out to be 47,780. Now, I changed my mind because remember, I was going to take natural log of both sides. You know what will be better this time? How about we take log of both sides? Why? Look at the base. The base is 10. So I think it's a brilliant idea if we take log of both sides instead of natural log of both sides, because log of 10, hold on, I'm going to go grab that baby real quick. Log of 10 is going to just turn into 1. 1 second. You want to sit right here with mommy? All right, so take a look. The reason we take log of both sides is so that we can bring this exponent down using the log property, the power property of logarithm. Oh, hold on. So that 8 plus 2x will come down. Come down in front of that log. So let's write it. I'm going to write down, oh my goodness, parenthesis. Here we go. 8 plus 2x. And then that's getting multiplied by what? That's getting multiplied by log 10. Stop it. Log 10. And that equals, on the other side of the equal sign, we have log 48,780. Alrighty. Log 10. I know, you can check this on your calculator if you want to. But this is just 1. This is just 1. It is. So the left side of the equal sign is just going to be 8 plus 2x. And that equals log 48,780. Okay, let's solve for x then. Subtract 8 from both sides. Minus 8. Minus 8. But we can't really subtract 8 from that log expression, so we're just going to write it next to each other. So like this. 2x equals log 48,780. You close that parenthesis. Make sure to close the parenthesis and then put the minus 8. Doing good. Let's go ahead and divide everything by 2. I'll just divide the whole thing by 2 on this right side. No. Okay, so we got the final answer. X is exactly log 48,780 minus 8 all over 2. I need to get the decimal of this now. So let's go type this into a scientific calculator. So guys, like I talked about in class, if you want to go with log, that's okay. If you want to go with natural log, that's okay too. But the reason I picked log, the common log this time, is because the base was 10. If the base was e, I would just take natural log. So this is log, L-O-G, parenthesis, 48780, close the parenthesis, minus 8, and I'll divide that by 2. The answer is negative 1.6559. And unlike logarithmic equations, you do not have to check the answer unless you really want to. But not because, like remember in logarithmic equations, we had to check our solutions because even if it was a solution to this extraneous equation that we wrote in the middle of a problem, if it didn't satisfy the original equation, like if it gave us a negative log argument, then we had to say, oh, this solution is an extraneous solution, therefore this equation has no solution. But you don't. What I'm saying is you don't have to do that for exponential equations. If you plug this in, it's gonna work. So I'm done solving. I think I solved just 2 additional equations over here. Okay, but I will go ahead and maybe stop and process this video so that I can come back and show you the other 4 on the other side, okay?